Good afternoon. How many of you here are Tableau Server system administrators? Looks like I'm in the right place. Well, I bet I know a fear that you may have, something that may even keep you up at night. Well, today we're going to show you some ways of setting up Tableau Server to be more robust against failure, so you'll never have to worry about this again. I'm Carlton Findley. I'm a software developer on Tableau Server.
And I'm Dan Scott. I'm a staff engineer, also working on Tableau Server.
So I'm going to go ahead and take it from here, and Dan will join us back in a little bit. So today we're going to talk about setting up a highly available Tableau Server cluster. We're going to talk about some new features and the HA story related to those. We're going to cover what to do when things go wrong. We've got some advanced tips and tricks for you. And as a bonus, we're going to cover disaster recovery a little bit. We'll have time for Q&A at the end, so if you just hold your questions till then. So what is high availability, or HA? Well, it's making sure that your system is available for use with minimum downtime. And it's often measured or expressed as a percentage of uptime. So how do we achieve this? The main thing we're trying to do is eliminate single points of failure. And we can do this by introducing redundancy into the system. Second, if we are not able to eliminate a single point of failure, we want to detect that and fail over to a standby instance. And another way is we can outsource our high availability. Let's take a look at some of the Tableau Server processes. So we're going to group them into a couple of main groups. Application processes like Application Server, VizQL Server, and Backgrounder. We've also got some new services we'll take a look at, including some microservices and some new other services. And then we've got TSM processes. And these are the processes which let you manage the server itself. We can also look at the HA strategy that we use with each of these processes. So the basic one is we just use redundancy. All these services, Application Server, Backgrounder, and so forth, we can put multiple instances of these processes on a machine, or we can put them across multiple machines to achieve that redundancy. There are some processes which are limited to having only one per machine. And so for that, we really have to have multiple machines in order to make those redundant. The repository is limited to having a single active read-write instance in the entire cluster. And so for this one, we're going to have to use a standby in order to make this highly available. The coordination service enables highly reliable distributed coordination. And it uses a quorum strategy, which is basically a majority vote. And so for this to work, we have to have an odd number of nodes, either 3 or 5. And finally, we've got a couple services which are limited to just one instance in your cluster, and that's the controller and licensing. And we'll take a look at that a little later. So let's take a look at a Tableau Server and configure it for HA. So this might be something that you would start out installing on a single machine. And you've got application processes like we talked about up at the top here. And then we also have our TSM processes. So for right now, let's go ahead and focus on the application processes. So out of the box, we have some basic resiliency built into the system. So if a service goes down, it's going to be restarted automatically by our services manager. And it could take a couple of minutes for this process to happen, but it will come back up if it's able to. In addition, these processes, which are in teal, you can add multiple instances even on a single node. So you can add, I'm just putting the number 2 here, but you can add 4 backgrounders or 2 viz portals and so on to configure it the way that you want to take advantage of the resources of that machine. So at this point, we've got our machine set up, and we've got the processes that are able to be doubled up, more highly available than they were, and that gives us a start on HA. Dan, I asked for you to save your questions till the end, but since you're my co-presenter, I guess I'll have to make an exception.
Yeah, so I just wanted to ask a couple things about this. One, I mean, I see how you've got those processes in teal. You've got them, doubled up there. So if one of those processes dies, you still have another one running that can handle load, right? So that's great, but you've got all these other processes sitting in there that you only have one instance of, like, where is one? Like Elasticserver or Gateway. And if one of those things died, or even worse, if the entire cluster died, or the entire node, I should say, died, then that's it. I mean, you're out of business, right? So what's the plan?
Yeah, that's a good point. And at this point, if you were to lose some of these processes, which are limited to being one on each node, or the entire machine goes away, we have to start thinking about adding additional machines to our cluster. So let's take a look at that now. So here's our node 1, and here are all the services. We've collapsed it just a little bit more. And now let's go ahead and add some more machines to our cluster. We can do this by running the installer on our other machines and using TSM to add them to our cluster. And you can see that there's a couple of processes that they have on them right out of the box. A couple of TSM processes and the cluster controller process. So how do we make the rest of these highly available in our cluster? Let's first talk about the repository and the file store and the data engine. So between these processes, we're managing all of the state and the persistent data for your server. So these are really important. And if we first take a look at the data engine and file store, these two work together as a team. The data engine creates extracts, and it also processes queries. And the file store manages those extract files. And so these are pretty important processes, and you are limited to only one on each machine. So let's go ahead and put these across all the machines in our cluster, and you can see that now we've got these highly available. File store, in addition, when it's on multiple machines, is going to start replicating those extracts across to multiple machines as well. So in addition to having that service redundant, you've got your files now stored. So if you were to lose one machine, your files would still be safe on another machine. Next, we'll talk about the repository. So the repository is our Postgres database, and we're limited to having one read-write instance in our cluster at a time. So in order to make this highly available, what we need to do is to add a standby. And we can go ahead and put this on node 2. And what this does is the passive repository, or standby, is constantly being replicated, or getting the data from the active repository. That data is constantly being streamed over to the passive repository. And so you've got a copy of this database data in both places. And if the active repository were to go down, there would be a failover process, which happens, and it would switch over to the passive. And so this is what we need to do to make the repository highly available. The rest of these processes are a bit easier to consider because they're basically stateless, and to add redundancy to the system and eliminate these single points of failure, we're just going to go ahead and put them across all the machines like this. So now we've got everything configured, all of our processes on our server configured for HA, and we want to point our users to this. And so how can we do this? Well, one way we could do is just give them a list of these machines and say, well, you pick the machine you want and go to it. This isn't a really good way to do it. It's just not very practical, and if the machine they're working on were to go down, they would experience an interruption in their work. So a really common strategy that we use is to use an external load balancer. So you can use an external load balancer. You configure all of your servers into the ELB, and then you just point your users at the ELB. So there we go. Oh, Dan again. I see you have another question.
Yeah. So you just finished telling us that in order to be highly available, you need to have redundant instances. So you've been blowing out all these redundant processes across these nodes. And then I'm looking here and I see this external load balancer, which looks like just a single thing. Have you not just introduced a single point of failure? How is that highly available?
That's a good point. It does look like that. But in this case, what we're doing is we're outsourcing our high availability story. So the ELB itself is a service that we use, which is itself highly available. And so in this case, we're using that to make our server more highly available. So now we're done with the application processes. So now let's take a look at the TSM processes. So here's our server now from the point of view of the TSM processes. The application processes have been collapsed, and our TSM processes are expanded, and you can see them. And you can see that across these machines, each of them have two services in common, even on the machines which have just been recently added. And that's the agent, which installs and uninstalls services. It starts and stops them, and it configures them. And the service manager is that one which, if a process dies unexpectedly, it'll restart it. The next thing we want to talk about is the coordination service. So, like I said, this provides a highly reliable distributed coordination, which is really important to support the HA story of some of our other processes, such as our repository failover, TSM itself, this is where all the configuration information is distributed, and our search and browse process. So we really need to have this highly available. When you just install your first node, you get one copy of it, but when we move to a multi-node cluster, we have to make it highly available. And we do this by putting it on an odd number of nodes, and 3 is a really ideal number, so we've taken care of this. Next, we'll talk about the client file service. So the client file service handles configuration files for your server, such as custom logos, SSL certificates, and the like. And it's basically just used when you're configuring your server, but you do want those files to be reproduced on other machines so that if you use one, you're not going to lose all of those files. So all we have to do is put this on one other machine, and that's highly available. The last two processes here are the controller and the licensing process. And they're singletons. We can only have one of these within our cluster. And we'll talk a little later about what we can do about those. But basically for now, TSM services are fully configured for HA. We're always adding new features to Tableau Server. And I'd like to just introduce some of those features and also talk about their HA stories. So we've been developing a lot of new services as microservices, and for deployment purposes, we've grouped them into a couple different groups, interactive and non-interactive, and we've put them into containers which get deployed. So the interactive container gets deployed with the application server. The non-interactive container gets deployed with the backgrounder. So their HA story is basically duplicating those across the different machines. Ask Data is a new service. This provides our NLP service and natural language processing. And it involves a new Ask Data service, as well as an Elastic service, which provides search capabilities. And the webhooks feature includes a webhook service and a messaging service. So let's take a look at how these would be made highly available in your cluster. So the microservice containers at the top, and Ask Data and the Elastic service, these you can put across all your machines. Currently, webhooks and the messaging service are limited to being on a single machine, but you can put them on any machine that you want to. So let's go ahead and make these redundant, and we put them across our cluster. And in addition, the microservices containers can be, you can have multiple instances on each machine. We've added some specialized capability in the form of add-ons, which you may have heard about. There's the data management add-on and the server management add-on. So let's just we'll take a quick look at those. With the data management add-on, you have, it adds prep conductor and catalog. Prep conductor adds a new service, the prep conductor service, and this gets deployed wherever wherever there's a backgrounder with flow processing enabled. And so basically its high availability story is that it gets put on, if you have a backgrounder on multiple nodes and you have flow processing enabled on those, it's going to get prep conductor. Catalog is made up of a number of microservices, which are in both the interactive and non-interactive containers. And in addition, there's a database, which is stored in the repository. So it shares the HA stories of those respective services. The server management add-on adds a bunch of cool stuff if you're a server administrator for resource monitoring and content migration. There's another presentation tomorrow which goes into detail on this, and I think that would be maybe of interest to you, and we've got a link to that at the end of this presentation. But for now, what I want to talk about is the external repository and the external storage, which are the last two here. These are of interest because they're examples of the outsourcing of our HA, what we talked about earlier with the external load balancer. So with the external repository, if you're running in AWS, you can use RDS to replace your active and passive repositories. And there's some nice things about this. You can set up RDS to be highly available, and you can externalize that and take advantage of all the features that RDS has to offer. External storage is something that's coming soon, and what it does is let you configure Tableau Server to use network share. And so you can take advantage of your managed storage solutions, such as SAN or NAS, and that managed storage will provide the high availability for your files, and this replaces the file store component. So I'm going to hand off to Dan now.
All right, so Carlton has kind of given us the rundown on how you configure your server to be highly available. And so, you look at that, it sounds pretty good. It's all rainbows and unicorns, right? So you can be off at the beach, sipping your Mai Tai and never worry about anything. Unfortunately, you see the title of my part right here. It does not say if things go wrong, it says when things go wrong, because you know that something is going to go wrong. And I'm going to focus on what is more or less the worst thing that can go wrong for you if you've set things up properly for HA. And let's see, get myself armed with a clicker here. Yes, okay. I'm going to talk about node failure. And there are really two types of node failure. One is what I would call ordinary node failure. The other one is a failure of the initial node, right? The initial node's a bit special. And so what I want to do is I'll start out and I'll talk about what happens, yipes, what happens if you fall over the timer. I'll talk about what happens if you have an ordinary failure, and then we'll kind of extend that to talk about the extra part that makes initial node failure special. All right, so let's say that node 2 goes down. Basically, the idea of what you have to do is you're going to have to, first check to see if you can get node 2 back again easily, right? Because maybe the problem is that somebody tripped over the power cord, or there's some minor hardware replacement or something, and once that's done, the node just comes back up and everything's great. Saves you a lot of trouble. But if that's not the case, then what you need to do is you need to drop this node and then replace it with another node and get it loaded up with the services. That is essentially the idea. We'll talk a little bit about some of the details. So you'd think that dropping a node would be just like a no-brainer, just, hey, TSM, drop this node and let's get on with things. But it turns out there's a little bit of trickiness that can be involved there. One of them is, let's say this node that we're dropping has a file store on it. And by the way, if this were configured for HA in a 3-node cluster, it should probably have a file store on it. So say it does. In order to drop a node with a file store, you have to decommission the file store. So how many of you here know what that actually means? What happens when you decommission a file store? Sounds like a battleship or something. What happens when you decommission a file store? Anybody know? All right. Okay, I'll tell you here. What happens, remember Carlton was telling us that the file store is constantly synchronizing files. You add like an extract somewhere, it goes in one of the file store nodes, and then rapidly gets picked up and moved to all of the other file store nodes. So if I have a node failure, well, if I want to remove a node, then what do I want to do? Well, at any given moment in time, there may be certain files that are in flight. I just added it to, let's say, node 2. It just got on there, and I'm just about to move it to the other nodes, but maybe it hasn't happened yet. If I say I want to remove node 2, now I'm not talking about a failure, just an ordinary removal, then before I get rid of node 2, it's going to go, wait, I need to move the files that haven't yet made it to the other nodes over to the other nodes. And that's what decommissioning is all about. It's saying the node that I'm decommissioning needs to move any files that only it has and make sure they get out to other nodes. Well, that's a problem here, right? Because this particular node died. And if I can't tell it to decommission, it's not listening, right? So I can't normally remove a node without decommissioning unless I force decommission. And so that's what I do. Now, this is one of those little warts that we didn't see when Carlton was giving us the rainbows and unicorns. There is a possibility for data loss there. If I have to force decommission, I got a file or two that didn't make it off of node 2. Well, guess what? They didn't make it off. Now, maybe I can get the disk out of there and find those files and get them moved over manually or something. There are possibilities, but I can't, it's not perfect. All right, I have to force decommission the file store. Well, another thing is if coordination service exists there, well, at this moment when it's failed, I have a cluster of 3 nodes, one of which is dead, and I can say that I still have 3 instances of coordination service, because remember what the rules are for coordination service? Quorum-based. Got to have an odd number of nodes. So I could have 1, I can have 3, I can have 5, and here we're HA, so we have 3. But as soon as I say I'm going to remove this node, that's going to turn it into a cluster of 2 nodes, 2 working nodes, 2 nodes, and I can't have an odd number on 2 nodes unless that odd number is 1. And so that means I'm going to have to redeploy my coordination service so that I'm only going to have it on 1 node after I remove this. And there's actually even one more thing there that I forgot to get up there on this slide, and that is, what if we had the repository on node 1 and node 3, and node 2 died? Once I remove node 2, this is going to turn into a 2-node cluster, and you can't have a 2-node cluster with an active and a passive repository. It's against the rules, right? And so that means that in that case, we would also, in order to remove this node, we would have to remove repository from one of the other 2 nodes. Otherwise, it's just not going to go for it. So it's a little tricky. There are these tricky rules. Now, the good news is, and I've got this reference down here, that if you get a node failure, there's like a sequence of steps to go through, and it does cover all this material, because I don't expect that people are going to remember this stuff. What I'm hoping for is to kind of make it make sense to you, right? Why things are kind of the way that they are. All right, so let's move forward. All right, so we've removed it, it's gone, now we have a 2-node cluster, and then we need to bring it back and become a 3-node cluster. So we install on a fresh node, we load it up with the missing processes, we start things up, we're good to go. On to the more complicated case, right? The initial node failure. So what is it that makes initial node failure more complicated than just ordinary node failure? Well, it's these. Remember Carlton mentioned that these are the singleton processes. You can only have 1 of each of these in your entire cluster. So we're going to have to deal with these specially. And the first thing you would, well, let's look at what happens, right, when it goes down. So the first thing about this is do not panic, right? Just because they were singleton processes and just because they're now gone does not mean that your Tableau server is down, okay? Actually, it's still running, but the clock is ticking, right? Basically, what happens is you get a grace period for your licensing, okay? You know, at Tableau, we're nice, but we're not nice enough to just let you go indefinitely without being licensed, so there are limits on that. You get up to 72 hours. And here's another blemish. Up to 72 hours, but I don't know how long, all right? It could actually be a very short period of time, or it could be the full 72 hours. So the clock is ticking, and that bomb will go off at some point, and you don't actually know when. Not great, but it is what it is. So as before, the first thing really is to try to repair the node. If you can do that, great. Okay? But if you can't, then the first thing that you're going to want to do is to move the TSM controller over there to another node, and we'll just use node 2. Okay? But there's a problem with this. There's kind of a logical problem, because what do you normally use to move processes around between the nodes of Tableau cluster? You use TSM, right. And what is the process through which you talk to TSM? The TSM controller, right? So this is your basic chicken and egg problem, right? Because you'd like to move things around, but the only way you have to move things around is the thing you're trying to move around, and you can't talk to it. So a chicken and egg problem, but Tableau developers have got your back. We have our chicken recover script, right? Instant chicken. Well, all right, I'm lying. We don't have that much fun. But instead, we have something very similar, which is the controller recover script, which is called move TSM controller. So this is something that happens outside of TSM itself. It's just a script that you run. And when you run it, it'll move the controller over there to the designated node. Now that you've got the controller over there, you can go on and do some other stuff. For example, you can now stop Tableau Server, because guess what? TSM stop will now work. You want to also move the licensing process off that first node. So move the licensing process over there, and you actually will need to restart the controller after you do that. It's kind of an oddity. Activate the license keys on the new node. And then, where this is going to resemble a lot what we did before, right? We need to remove node 1 from the cluster. All the same considerations about what processes were running on it and what you have to do, those all still apply, but we're going to just pass over that this time. And then we create a new one and put the necessary processes into it. And then we start start TSM up again, start the server, right? So we're back in business at this point. So this is how you handle the node failure. I would respond to the question, but let's hold that till the end, okay? Thanks. So now I want to move into a section here on some advanced tips and tricks. The first one is to isolate the coordination service on dedicated nodes. So why? Well, Carlton actually talked with us a little bit earlier about some of the things that the coordination service does. And if you don't have a working coordination service, your repository might fail over for no particular reason, because we use the coordination service in the way that we manage failover between primary and secondary repositories. Search service could stop working. Search service is actually Apache Solr, and Solr Cloud in particular, and Solr Cloud uses Zookeeper. Have your Zookeeper fail? I didn't say. And coordination service is also Zookeeper, right? So if Zookeeper is down, then the Solr search service, Solr Cloud, is not going to work right. And also TSM uses it for accessing various kinds of data. This is that shared state across the cluster, and if it's not working, TSM isn't going to work reliably either. These are pretty important things to have fail on you, so it's important to keep your coordination service working. Now, why would it not work? Well, it turns out there's one major problem that tends to exist with Zookeeper, and that is that it doesn't deal well with situations where it's limited in its disk I/O. And in fact, they recommend that you give it dedicated disk I/O. Well, that's not normally the case in a Tableau Server installation. And so when we first rolled this out back in, was it 9.0, I think, we actually saw a lot of cases where customers who were using it in kind of underpowered servers or on servers with lots of heavy-duty processes that were really stressing it, they would see instances where Zookeeper wasn't functioning well because it couldn't write to disk in a timely way. And so this happens, and this is actually the reason why there's a 5-minute wait before you'll see a failover of your database from primary to secondary. That wait is because we've seen instances where Zookeeper was confused over a relatively long period of time. And so we ended up having to give it a relatively long time before we said, okay, we're pretty sure now, go ahead and fail over. This is a viz from LogShark. This would be coming from the Zookeeper logs. And Zookeeper logs information about excessively long fsync times. The fsync time is how long it takes to get the data actually written to disk. Now, there's a moderate sprinkling of kind of unfortunate-looking fsync times here, but it's not too bad. I mean, this is this is over days. We're seeing a few instances, nothing too much to worry about. But if you saw like just clouds of this kind of stuff happening here, you would be in kind of a bad situation. All right, so let's say that we've decided, we want to avoid any potential for that. We'd like our coordination service to be working really well. And so what to do? Well, we're going to deploy 3 additional nodes for full isolation. So we're just going to have these nodes dedicated to coordination service. That's it. So how do you do that? It's really pretty simple. Stop the server, run the Tableau Server installer, right? You need to get these new nodes and get them added in by using the TSM Web UI. Add those 3 new nodes. And then what you want to do is a deploy coordination service command here that is going to deploy the coordination service onto the 3 new nodes. And by the way this works is that you get your coordination service on the 3 new nodes, but you actually still have the remnants of your coordination service that you had originally deployed. And that's why at the end here you have to run this cleanup coordination service. Oh, and I should mention in the middle here, that command there to deploy coordination service does not happen in a finger snap. You might as well figure on going out and getting a little coffee for yourself. But when you come back, you can try running this TSM status V, and you may see it giving you an error response. That just means you need more coffee, right? But eventually it's going to come back and say things are okay, and then and actually, you can see over there, after you start it up, that's what it's going to look like on those 3 servers. They have a certain minimal number of processes, but the important ones for our purpose are those coordination service processes. All right, my second tip here is on optimizing the server for workload and HA. All right, so why do we do this? What am I talking about when I say that? Everybody's server installation is kind of unique, right? They do different things in different amounts, and if you're trying to scale it up, there are certain things that you particularly need to have scaled, but other things you may have plenty of already. You don't need to scale them at all. And the most normal forms of this would be like you need more interactive capability like your Viz portals, your VisQL servers, and all of this, so that as users interact, they can quickly get responses. Or conversely, maybe you have need for more background type processes extract refreshes, flows, subscription work. Maybe that's where your server is particularly busy. So we're going to do a somewhat larger example here. This has got 9 nodes in this cluster. And I should mention, you look at this, and with the core-based licensing, people go, 9 nodes, all right, that's going to kill me. With subscription licensing, of course, that's not an issue, right? So you can say, all right, I don't have to worry about the added cost of licensing. Yes, I may have to manage added servers, and obviously there's costs there, but but this is generally a lower cost. But even if you have core licensing, there's something to pick up from this, right? So this first group right here is what I was talking about with interactive workloads. So if you need more interactive workload capability, you can just add additional machines with similar configurations. The second group are the background job ones. And it's the same story, right? If I need more background job work, I roll out additional background job nodes that look like this. Then I think I talked about this a little bit earlier. These are dedicated nodes for the repository. And one thing about the repository that's kind of different from most of the other stuff is, remember, you can only have one actively running repository at any given moment in time. And that means that you have no ability to scale horizontally with it. And so you can only scale vertically, and that means that you need to either provide more capable hardware on which the repository is running, or the first step would be to say, well, I won't change the hardware, but at least I can get all these other crappy processes off of there and running somewhere else, right? So, and also, most of these other processes talk to the repository. So it can be very, do I have something here? Oh, okay. So most of them talk to the repository, so it's a problem for everyone if you're not getting good performance there. The final group is the coordination service, and remember, hey, we rolled out 3 nodes specifically for coordination service, and here they are again in this one. Tip number 3, deploying to the public cloud, right? So why would you want to deploy to the public cloud? There are multiple reasons, and one of them is availability zones. Typically, in your own, if you're hosting it yourself, you don't really have this concept. We'll talk about that a little bit in a second. Also, you get easy server management when you're running in the cloud. If you want to do something like, oh, I think I need to increase the disk space on this machine, it's easy to do. Or, wow, I need a more capable machine. Let me just bump up the instance here. That's generally a lot easier than having to manage that in-house. And also, there's an additional thing here. If you're running an AWS in particular, and you have that server management add-on, then you can outsource the repository to RDS. That's the Amazon's relational database service, something that Carlton mentioned earlier. But that's another thing you can do. So about regions, right? So we have regions, we have availability zones. Regions are typically geographically separated, and you're not going to be able to set up your Tableau server with one node in this region and one node in that region. I mean, I don't know, maybe you could, right? But not if you actually want to see results anytime soon. That's just way too much latency between them. But availability zones are a different story. There, the cloud providers ensure that, first off, there's a great deal of separation of infrastructure, like redundant power, networking, and connectivity there. But the availability zones are connected with low latency networking, right? So it actually works to have nodes of a single cluster deployed into different availability zones within the same region. And when you do that, you get some protection against the kind of failure that would take every node down. An obvious case is an electrical failure, right? this is not, your nodes don't act independently. If the power goes off to everybody, then they're all going down, and that's just that. So, but with availability zones, that's not going to happen because it's very much independent. This is just kind of a diagram that shows a layout in the different availability zones. And also, let's see, this is the server management part with the RDS thing. I wanted to talk a little bit about some of the benefits and downsides. So the idea of this one is, instead of using the built-in repository, that is Postgres database, that is in Tableau Server, instead you set up an RDS instance within AWS, and then you tell Tableau Server, hey, when you want to use the repository, it's over there. And that means, so the good thing about that is that AWS has this transparent failover that happens if you set the thing up to use multiple availability zones, and you can configure it to have transparent failover. And so this is a case, right, where we would be outsourcing HA, right? So also, you can adjust the resources for those RDS instances. As I mentioned earlier, it's really easy to do that in AWS. And in our own online system, we've had to do this multiple times. We'll be looking at some pod and we'll go, wow, the database is looking really busy there. We need to do something about that. Or it's running out of disk space. That one's especially easy because you can up the disk space. You don't even have to take the server down. Very convenient. So that's really nice. But it's not perfect. There are some downsides. One is that you actually have to set up the RDS instance. Tableau will not automatically do that for you, right? So you set it up, you configure it, and then later you'll just tell Tableau Server, it's over here, okay? Also, if a new version of Tableau Server comes out that requires a later version of Postgres, then you're going to have to go over there to your RDS instance and say, hey, upgrade to Postgres version such and such, and then you can use the upgraded version of Tableau Server. So it's not quite seamless. You get some advantages, you have some disadvantages. What works for you is going to depend on you, right? All right, so the last part here that I want to talk about goes beyond what is traditionally considered high availability, but in my mind, it's just part of the spectrum. With high availability, you're trying to make sure that your service is up, doesn't go down, stays up as much as you can, right? Well, in the case of a disaster that wipes out your data center, you can expect that there's going to be some downtime, but you're still facing the task of how do I ensure that my service is available as much as possible? And this is going to mean that I'm going to have to bring up Tableau Server somewhere else because that data center is flooded or something, right? There's no hope for it. And so I want to just talk a little bit about this and what you would do to take care of the problem. So you don't want to see that bearing down on your data center, but it could happen. Let's talk about some basic concepts, RPO and RTO. So recovery point objective, RPO, is, let's see if I can, yes, I have my laser pointer. All right, so between the time of the last backup and when this disaster happens, that's your recovery point objective, and it's kind of a measure of how much time worth of data are you going to lose? Because, hey, I didn't back it up past this point, and then it got flooded, and that's it. I'm going to have to accept that I had some data loss. Then, recovery time objective is the other part of this. All right, I was taking backups and everything, and I moved them out of this region, right? Because that's no good at all if you leave it there to get flooded. So I moved it out, and now I have to bring up my new system that everybody's going to connect to over in this different data center. How long is that going to take me to do? That's my recovery time objective. So how long do we wait and not have a service? Okay. All right, so just some basics on this, right? You need to take regular backups. The more frequently you take them, the better your recovery point objective is going to be, the less data loss you'll have. So, have enough disk space, move the backup files out of there because else you'll just lose them with the disaster, and, secure them and their destination. All right, so talk about reducing RTO. There's a spectrum of things that you can do, and they go from having a high RTO, that's bad, right, high RTO, but very little work for you, up to having a very low RTO, but yeah, it's more work and more expense. So what do you do, basically? Oops, lost that. Go back. Why is it not going backwards? What's that? Backward is not working. All right, well, I'll describe the missing slide. All right, so, so at the low end of the spectrum is where you have basically just got you've got a spot where you're going to bring it up, but you don't have anything installed. There's no Tableau Server there. And this is very little work for you. But when it comes time, what are you going to have to do? You're going to have to install Tableau Server. You're going to have to take your backups, restore your backups to the new server. This is going to take hours if you're super fast, and it could take days, right, before you bring it up. So, hey, thank you. All right. The intermediate one there is when you have a cold standby cluster. And so with that, you've got Tableau Server installed, but you're not constantly restoring backups to it. It's not really ready to go. And if you're not kind of diligent, did you actually upgrade it to the latest version? Right, that could slow you down. So, but reliably, you should be able to bring a cold standby cluster up in a few hours. And then the best is if you have this dedicated DR cluster, you're constantly bringing in your backups from the main facility. You constantly restore them. It's ready to run at any given time, and it's just a matter of switching over to it as something happens. But that's obviously the most work and the most expense. So this is just kind of a diagram of what goes on. So everything is, happy, it's working, the primary cluster. You are synchronizing, that is, constantly restoring backups there from it to the disaster recovery one. Along comes the disaster, and then you redirect traffic to the DR cluster, which is running, and everything is good. All right, so I got a few little questions here at the end. First one, which add-on provides the external repository feature? Server management add-on, good. Which DR concept relates to the time of the last backup? The recovery point objective or the recovery time objective? RPO, recovery point objective. Why does it take at least 3 nodes to be HA? Quorum, right. It's the coordination service that's doing that, because in order to duplicate that at all, it has to be an odd number. So you can't have multiple ones running without having at least 3. And so that's why you've got to have at least 3 nodes in order to be HA. All right, so after all this, hopefully this is you sleeping peacefully, everything's deployed well, and you know what to do when something goes wrong. All right, so there's a survey. I'm sure you've seen this before. And we're now ready for questions.